Welcome to YouTube channel scientific underscore math. We are solving a system of linear equation using the LU decomposition method. In earlier lecture, we discussed Gauss elimination method, and we have also discussed what is LU decomposition. In earlier lectures, I will provide the link in video description. You can watch. Okay. So in this lecture, we discuss Doolittle method, and we will also solve example related to the Doolittle method. And in the next lecture, we will write a MATLAB code for the Doolittle method. So let's start today lecture, and we will discuss the Doolittle method for solving a system of linear equation. LU decomposition with Doolittle method. And what is Doolittle method? The LU decomposition using Doolittle method is a method for solving system of linear equation. And we write the system of linear equation in this form, a matrix form. Ax is equal to b. This one is the coefficient matrix, and this is the matrix x, or the column matrix x, and this one is the column matrix b. Okay, column matrix b, sorry, matrix. Okay, and this one is column matrix x. So in this method, the coefficient matrix, this one is the coefficient matrix A, and this is the square matrix, always is decomposed into the product of the lower triangular and the upper triangular square matrices. Okay, where the diagonal entries of the matrix L, this one is the lower triangular matrix, are all ones, means the diagonal entries of this matrix will be 1. Okay, in Doolittle method, the LU decomposition has the form: we decompose the coefficient matrix into the product of lower triangular matrix and the upper triangular matrix. Here the coefficient matrix is the square matrix, and these two matrices will also be the square matrices. Okay, so in general form, the coefficient matrix we have, this one is the A square matrix of order n cross n. Okay, and this one is A n cross n. This one is decomposed into the product of lower triangular matrix and the upper triangular matrix. Okay, here we can see that all the entries are one diagonal entries, and above the diagonal entries all are 0. So this one is the lower triangular matrix, and this one is the upper triangular matrix. We can see below the diagonal entries all are 0. So we decompose the coefficient matrix into the product of lower triangular matrix and the upper triangular matrix. For the case of system of three equations, the matrix of coefficient A is 3 cross 3, and the LU decomposition has the form. So first we write the system of linear equation in matrix form, that is uh, Ax which is equal to B, and the lower triangle and the coefficient matrix A is decomposed into the lower triangular matrix and the upper triangular matrix. So we have LU decomposition form of the coefficient matrix A of order 3 cross 3, and is and this one, this is the lower triangular matrix, and this is the upper triangular matrix. Okay, so next, the coefficient matrix A, this one is equal to the lower triangular matrix and the upper triangular matrix. We multiply the lower triangular matrix with the upper triangular matrix, and after multiplying we get this form, the product of both these matrices. And now we compare this matrix with the coefficient matrix, and the entries of the product of lower triangular matrix with the entries of the coefficient matrix. Okay, so to find the values of unknown like L21, L23, L31, L32, U11, U12, U13, U22, U23, and U24. Okay, so we have to find all these unknowns by comparing the entries of or the entries of this matrix with the entries of the coefficient matrix. So first we compare this one with this one, and with this entry to this entry and this entry to this one to find the values of unknown. So here u11 is equal to a11, u12 is equal to a12, and u13 is equal to a13. Next we compare this row with the coefficient matrix with and this row, and this one is equal to a21. Here we can see that, and we have to find, here we can see that we have to find L21. So we rearrange this equation to find the values of L21. Next we will compare this one to this A22. Okay, here we can see that L21 U12 is equal to A22 is equal to A22, and here we have to find the value of U a value of unknown, which one is u22. Here we have to find the value of u22. So we rearrange this equation to find the value of a2. So we will get from this equation the value of u22. Next we will compare this to this a coefficient matrix entry. So here we can see that this is equal to a23, and we have to find the value of u23 like that. So we will rearrange this equation, and then we will get the value of u23 after substituting the value of u23, L21, and u13. Okay, so similarly now we compare the third row of this matrix with the third row of the coefficient matrix, and here we can see that this will be equal to a31, and this is equal to a31. Now we want to find the value of L31, so we will rearrange this equation to find the value of L31, and now we after substituting a31 and u11, we will get the value of a31, and next we will compare this entry to with this one a32. Okay, so here we can see that this is equal to a32, and we have to find what value next, L32. So we again rearrange this equation to find the value of L32, and after substituting all these values we will get the value of L32, and the last one we have this equation, and we compare this one to this entry of the coefficient matrix, and after rearranging this equation, because we have to find the value of u33, and so we rearrange this equation to find the value of L32, L33, and after substituting all these values in this equation we will get the value of u2 u33. Now in general form, for n cross n we have this one, like that the values of u we will get after changing the value of k and m, like m is equal to this one, l the loop for m is equal to this one, and we can find the value of l by this equation by changing the values of L, for changing the value of I. Okay, I and I is equal to k plus 1, k plus 1, k plus 2, and up to n. Okay, so now we discuss the example related to the LU decomposition with Doolittle method, and we solve one example. Example: solve the following set of linear equations using LU decomposition with the Doolittle method. So we have the given three system of linear equation, and first we write these equation in matrix form. Writing the given system of equations in matrix form, Ax is equal to b. This is the coefficient matrix X, and this one is the matrix B. Okay, so we write these equations in this form, matrix form, and here we have the matrix form, the of three system of linear equation. So this one is the coefficient matrix A, this is the matrix X, and this is the matrix B. Okay. First step we have the coefficient. The matrix of coefficient is first decomposed into the product of two matrices L and U. It's mean we decompose this matrix, the coefficient matrix, into the lower triangular matrix and the upper triangular matrix, like we have discussed the procedure of LU decomposition in a previously. Okay, so the coefficient matrix A is equal to the lower triangular matrix and the upper triangular matrix, and we have this one generally the lower triangular matrix, and this is the upper triangular matrix, and now we multiply these two matrices with each other. Then we compare the entries of product matrix will the coefficient with the entries of the coefficient matrix. Okay, so here we have the product of the lower triangular matrix and the upper triangular matrix, and this is equal to the coefficient matrix. Now we compare this entry of the LU matrix with the first entry of the coefficient matrix, and similarly for U12 and U13. So we have the values of U11, U12, and U13. Okay, so now we compare the second row entries of second row with the entries of the coefficient matrix second row, and this, so we have this U21 U11 will be equal to this one, and from this we will find the value of L21, and similarly for this one and this one, from this one we will get the value of this, and from this we will get the value of U22. So here we can see U12 U11 is equal to A21, this is the A21, and this is equal to A21 is 4. Okay, so we rearrange, we simplify this equation to find the value of L21. So L21 is equal to this one, and here we have L21, the value of L21. Next, we compare this entry with L with A22. Okay, and we find the value of U22. So here we have this equation, and we rearrange this equation to find the value of here will be plus U22. Okay, so we rearrange this equation to find the value of U22, and after rearranging we get this one. Now substitute the value of A22 minus L21 and U12. After substituting the value of all these unknowns, we get the value of U22. Now we compare this to this one, and from this equation we will get the value of U23. Okay, so here we have this equation, and we simplify this equation to find the value of U23, and U23 is equal to this one. Okay, so put the value of A23, that is 10, L21, and U13, and after simplifying we get the value of U23. Okay, so next we compare the entries of product matrix third row with the third row of the coefficient matrix, and this will be equal to this one, and this will be equal to this one, and this will be equal to 17. So again we arrange in this equation to find the value of L31. Okay, so this will be equal to this one, and after substituting the values of A31 U11, we get the value of L31. Now we compare this equation to this one, that is equal to A32. So A32, and again we rearrange this equation to find the value of U22, sorry, L32. Okay, so after rearranging we get this form, and after substituting and simplifying this equation we get the value of L32. Okay, so next this one is the last equation, and this is will be equal to A17, and this is A33. Okay, so we rearrange this equation to find the value of U33, and here we can see that after rearranging we get the simplified equation, and after substituting the values of all unknowns, and then after simplification we get the value of U33. Now we have the matrix, upper triangular matrix U and the lower triangular matrix. This one we have find all the values of upper triangular matrix and the lower triangular matrix. Okay, so next lower triangle, the coefficient matrix is now decomposed into the product of the upper triangular matrix and the lower triangular matrix. So we rewrite the equation, and this one is equal to this equation. We replace the coefficient matrix with the product of the upper triangular matrix and the lower triangular matrix, because the product of this matrix upper, lower and upper is again the coefficient matrix A. So we replace this A with the lower triangular matrix and the upper triangular matrix. So this is equal to we have this one like that, and this lower triangular matrix, upper triangular matrix into the matrix matrix X, and this is the matrix B. So to solve this equation, first we find the product of this one, the upper triangular matrix with the coefficient matrix. This is equal to any arbitrary matrix y of order 3 cross 1, because we have the system of linear equation, three system of linear equations. Okay, so this the arbitrary matrix will be the of same order of matrix X, and or the matrix B, or next to third step we have like the product of upper lower triangular matrix with the arbitrary matrix Y, which is equal to B. So this one is the second equation. To solve the first equation we will solve first the second equation, because here this is the arbitrary matrix. The values of we don't know the values of y1, y2 and y3, and this arbitrary matrix is of order 3 cross 1. Okay, 3 cross 1. So we don't know the values of y1, y2 and y3. So first we solve the equation to find the values of unknowns y1, y2 and y3. Then we put this values into this matrix, and then we solve the equation 1 for the values of x. Okay, so now the solution x is obtained in two steps. First we solve the equation 2 for y, and then the solution y is substituted into the equation 1 and then solved for x. So solving the equation 2 to get the values of unknowns y1, y2 and y3. Okay, so we solve this equation, and lower triangular matrix we have this one and this one. This is the arbitrary matrix, and this is the matrix B matrix. Okay, so here we use a forward substitution method. Okay, so we multiply first from first row to multiply first row with the matrix y, and then we multiply the second row with the matrix y, and then we multiply the third row with the matrix y. This one is the first, second row and third row with this matrix respectively, and will be equal to r 11, 28 and 31. So after multiplying the first row with the matrix y, we get the value y1 is equal to 11. Similarly, we get the value of y2 which is equal to 6. And after simplification, and similarly when we multiply r3 with the matrix y, we get the value of y3. So now we have get the value of the matrix y, and now we substitute this matrix into the equation 1 to find the values of x. Okay, so now solving the equation 1 and to get the values of unknowns x1, x2 and x3. So this one is the equation 1. Here we put the values of solution of y, and here we use backward substitution because first we multiply third row, okay, with the matrix x to find the value of x3. Then we multiply row 2 with the matrix x to find the value of x2. Then we multiply the first row with the matrix x to find the values of x1. Okay, so we get after multiplication the value of x3 is equal to 1, and after simplification and multiplication we get the value of x2 is 2, and similarly for x1 is equal to 3. So this is the solution of the system of linear equations, and by using the LU decomposition with Doolittle method. In next video we will write a MATLAB code